Welcome friends. Let's talk about an equipment whose origins go back to about 2300 BC. Without any doubt, one of the most important equipment even today in the modern ships, and probably the most reliable also, magnetic compass. There is a magnetic compass bowl that is supported inside this binnacle made of non-magnetic material. The main function of this binnacle is to provide support and protection for the compass bowl. However, the structure also provides the ideal support for the standard correction elements, namely the quadrantial correctors, the Flinders bars, and fore and aft athwartship permanent magnets. Healing error magnets are placed in a bucket arrangement on the center line of the binnacle, directly under the central position of the compass bowl. Let's talk about the various parts of the magnetic compass. The magnetic compass is secured inside this binnacle. The binnacle has a top cap which can be removed for taking bearings using an azimuth mirror. Also, the magnetic compass has two quadrantial correctors, one on the port side, one on the starboard side. This is the port side one, this is the starboard side one, also called Canville balls. These are used to correct the magnetic compass. Both the balls are supported using brackets, one on the port side, other on the starboard side. These brackets securely hold the Canville balls next to the magnetic compass always. If you look at the forward part of this binnacle, there is another magnetic compass corrector, the Flinders bars, which is always secured on the forward. Then in the aft, you have three hatches. Here, one on the top, one on the port side, one on the starboard sides. These hatches give us access to various other magnetic compass correctors like forward and aft correctors and port and starboard athwartship correctors. The magnetic compass binnacle is secured to ship's deck using these slewing bolts. These slewing bolts ensure that the magnetic compass securely stays to the ship's deck even in any kind of bad weather. Then you finally have a telescopic tube which passes under the binnacle through the deck of the bridge and then reaches the bridge so that we can take magnetic compass readings without any need to come on the Monkey Island. Compass bowl, manufactured in a high quality non-magnetic brass. This has a clear glass face over here and a frosted glass base at the bottom to diffuse the underside lighting. Both the faceplate and the frosted glass base are secured by a rubber lining gasket to prevent leaks from the bowl. Paints used in and out of this compass are bowl baked paints so that they do not cause any discoloration to the fluid which is inside. And the fluid will last for years because the paint is used of high quality. Brackets are fixed to the outside to connect the gimbal system. Here you have brackets to the bowl which will fix with the gimbal system. And a support is secured on the inside of the bowl to accommodate the pivot. So behind this magnetic card, there is a pivot which supports this card. So these are the gimbals. These gimbals support the magnetic bowl. And they have a hinge over here on the port and starboard and one in the forward and the aft. This is the lubber line, this black dot that you are seeing. This is marked inside the bowl in alignment with the ship's forward and aft center line. So this gives you the actual heading, magnetic heading of the ship at this moment. Then this is the compass card made of glass melamine or a mica. The diameter of the card varies. But a 10-inch bowl would expect a 7.5-inch diameter of the card. In the course of manufacture, the card is corrected by its magnetic moment to limit its speed of movement and then checked for friction. Cards are normally screen printed, so these prints are screen printed to indicate 3-figure degree notations and have cardinal and half cardinal points identified. Intermediate and bi points are indicated but not individually lettered. So you see these are the cardinal marks and intercardinal marks are marked, and you have the intermediate points are not named but they are marked over here on the compass card. A single circular magnet is placed beneath this card to produce the directive force required by the compass. So there is a single piece of round magnet which is below this card which helps it to align with the magnetic earth knot. And this is a TMC unit. So we have a digital magnetic display in the bridge which takes the reading from here and then projects the actual magnetic heading of the ship in a digital format on the bulkhead. Then there is a pivot point below this compass card which I can't show you because that is under this card, which is made of polished iridium. The pivot point effectively lowers the center of gravity of the card below the point of suspension. Mostly compasses are liquid filled compasses, as these are more stable than dry compasses, consequently making it an excellent steering compass. In modern ships, the magnetic compass employs an oily liquid derived from Bayol, which not only provides additional flotation to this card, but also lubricates the pivot and reduces motion of the card. You see now, if I am turning this, moving this compass bowl, the magnetic compass card is more or less stable. Now it has moved to 0 to 5 and now it's slowly coming back to its original compass heading, which is 0 to 2, as we saw in the repeater also, which is placed in the bridge. So it's quite stable because of the kind of liquid that is being used, and there is a pivot, as I told you, which lowers the weight of this bowl to the bottom, so it becomes more stable. And this liquid keep lubricating the pivot also, so it never stops working. That's why it is considered as one of the most reliable equipments on board. Then I used the word gimbals when I was explaining this compass bowl. So what does gimbling means? So gimbling means the slinging of the compass in such a manner that it remains horizontal at all times. So if ship rolls to starboard side, then the magnetic bowl will always stay horizontal, even in heavy seas. This is achieved by maintaining the compass bowl in horizontal position by two axis gimbal rings, one on the forward and aft center line and one in the port and starboard athwartship line. A telescopic reflector unit. This acts as a through deck repeater from the magnetic compass on the Monkey Island to inside the wheelhouse. Typically fitted in the fore part of the compass, it reflects the lubber line and the foremost part of the compass card inside the magnetic compass. Typically manufactured in PVC with brass fittings, it incorporates moisture-free sealed-in mirrors that are adjustable at eye level, and it helps us to read the magnetic compass heading easily inside the wheelhouse. So that's all, folks, about the basics of magnetic compass for now. There is much more to this topic, but that we will cover in another part of video some other day. Till then, adjust your magnets, keep your magnetic compass steady, and sail through the wide open oceans with confidence. Thank you.